Hello everyone, welcome back. We're going to cover section 1.5 and 1.6 together. So let's go ahead and jump right in. In example number 1, we need to solve for x. Now, I don't know about you, but personally fractions make me a little bit nervous. So we have a way to get rid of the fractions. So I'm going to just show you one method. So you can take this, since it's an equation, and we're going to multiply everything. We're multiplying both sides by whatever numbers are on the bottom of that fraction. So I'm going to multiply everything by a 4 and a 5. And you could multiply by 20. That's totally fine, but I'm going to multiply it by a 4 and a 5. So if I take that 3/4 x and I multiply it by 4 and 5, that's going to look like 3 times 4 times 5 over 4x minus 1 times 4 times 5 equals 7 times 4 times 5 over 5. So I did it to everything, and that's legal as long as you do it to everything. Well, I can see that these 4's will cancel, leaving me with a 15x minus 20 equals 28. And now I just have a two-step equation. Instead of having those fractions, that's a method to get rid of them. By no means is this the only method to solve, but it's just an option. Add your 20 to both sides. 15x equals 48. Divide by 15. X is 48 fifteenths. And then if you can reduce that, you want to, and that does reduce, we can go ahead and put a 3 into both of those. So x is equal to 16 fifths. In example number 2, just practicing that distributive property. This is going to look like a 10 minus 6x equals 8. Distribute that negative, minus 3x minus 6. Go ahead and move things all around. I'm just going to go ahead and add 3x to both sides. So I have 10 minus 3x equals, I can combine the 8 and the negative 6 to give me a positive 2. Then let's go ahead and subtract 10 from both sides. So negative 3x equals negative 8. Divide both sides by negative 3. X would be positive 8/3. Uh-oh, that got cut off a little bit. Let me scroll down for you. There you go. So just a reminder on how to solve equations. Yes, you might have fractions. Yes, you might have some distributing. And yes, you'll have answers that need to be fractions as well. So when we're solving, we might have some special cases. You might have something where it's an infinite solution. That would be like 5 equals 5 when you're all done. Okay, you have something that is true when you're all finished, but it doesn't say x equals 5. The x is now gone. Something like a no solution would be like a 2 equals 7. Okay, well the x's went away and we were left with a false solution, so then that would be a no solution. So we'll take a look at 2 of those and what we would expect to see. So just solving like normal, I would add 24x to both sides. So that would leave me with 7 equals 17. Well, that does not make any sense, so this is an example of a no solution. On this next one, if I add 1/3 x to both sides, I'm left with 3 equals 3. This would be an example of an all solution or an infinite solution, same thing, because it's a true statement. No matter what number I plug in, both sides will equal each other. We're going to give you some formulas here just to help when we go through some word problems. The motion or distance formula, d equals r times t. D represents your distance. R is your rate. And t is time. We also have a simple interest formula. I equals PRT. I is representing interest, how much money you will earn. P is principal, how much did you originally put in. R is still a rate, and T is still time. So those are just 2 that we will commonly use, and there could be some more as we go through as well. Okay, so all of these word problems I'm going to save for in class. I feel like it'll be more beneficial to talk with them together. But we will look at zeros of functions. So if you want to just find where I see example number 11. So a zero of a function is also known as an x-intercept. So remember that we're trying to find a number, comma, 0 as an ordered pair. You might also see it as your function equaling 0. So those are just a couple of different ways to think about the 0 of a function. So in this example, we want to find the 0 of that function 5x minus 9. Well, we can find a 0 when the y value is 0. So we're just going to say 0 equals 5x minus 9. Add 9 to both sides, divide by 5, x is 9/5, and then we can write that as an ordered pair, 9/5, comma 0, or we can write it as f of 9/5 gives me back 0. So when we're finding the 0 of a function, we're finding that x-intercept, or when y is 0, what is x? So just a little bit of different language there. Okay, we're going on to 1.6 now. So we're going to solve some inequalities here. So we're going to solve these two inequalities and graph them on a number line. When you're solving an inequality, I like to just draw a line down that inequality symbol just to remind myself that I'm moving across sides just like an equation. So the very first thing I would do is I would add 2x to both sides. 5x minus 5 is less than 6. Add 5. 5x is less than 11. Divide both sides by 5. X is less than 11/5. Now they want us to also graph this. So I'm going to actually graph it off to the side so I have some room. So I'm going to go ahead and graph the first example right here in green. So when you're graphing for me, please include 0 and then also include the number that you're graphing at. So 11/5 is just over 2. So I would have him maybe over here and I would just label that exactly how I see it, 11/5. Now remember, whenever we're graphing inequalities, you're going to have open or closed circles. When you're graphing, you might also see it as an open parenthesis or a closed bracket. So open would be if it's less than or greater than. Closed would be less than or equal, greater than or equal. On MyMathLab, when you're graphing online, it's going to use the parenthesis versus bracket. I don't care though when you're graphing for me on a test or a quiz if you use the open or closed circle. Totally doesn't matter. And then just remember we need to shade as well. So when I'm looking at our answer, less than 11/5. Okay, I know that's going to be open because it's just using the less than. So I'm going to go ahead and go open circle at 11/5. And then I need to decide if I'm shading left or right. Well, if x is on the left side, you just shade the direction that the arrow is pointing. So in this case, the arrow is pointing to the left. So I'm going to shade to the left, which means all numbers less than 11/5 are also solutions. All right, for part B, same exact thing. We're going to go ahead and solve for x. So the first thing that I would do here is I would add 7x. So that leaves me with 13 is greater than or equal to 17x minus 4. Add 4 to both sides. 17 is greater than or equal to 17x. Divide by 17. 1 is greater than or equal to x. Okay, so if we go ahead and try to graph this guy, and I will graph him down here in green. Again, I need 0, and then I need the number that I'm plotting. So I'm plotting 1. It's greater than or equal, so I know that I need a closed circle or a shaded in circle at 1. Now, because x is on the right side, I need to rewrite this so that x is on the left side. If I look at that symbol, it's eating 1. So when I rewrite it, it still needs to be eating 1. So then I can see the direction that that point is pointing is to the left. So I'm going to shade everything to the left. Okay, and I think that's all we're going to cover together. If you want a nice review of finding domains. You guys can do example 2 on your own. Hopefully you feel confident on doing that since our last lesson. And then we'll come back and talk about compound inequalities and all of those word problems that I skipped. So enjoy the rest of your night, and thank you guys for watching.